Welcome friend. In this video we see the analysis of frame by using cantilever method. So in this question I just take this simple example just for understanding the concept how to solve the cantilever method for this. Okay, so let's start. First of all, we see what are the assumptions we made for the calculation of cantilever method. For cantilever method we made two assumptions, that is the point of contraflexure in all the member lies at the midspan, and the second assumption, that is the direct stresses in the column. So this is one of the main assumptions in the cantilever method, that is the direct stresses in the column due to horizontal force are directly proportional to their distances from the centroidal axis of frame. So this is main assumptions. By using these two assumptions we are going to solve these questions. Okay, so here we have to calculate the centroidal axis because the direct stresses in the column are directly proportional to their distances from the centroidal axis. Hence our first step was the calculation of centroidal axis. We know how we calculate the centroidal axis. We know the form. We take one of the reference point. Here just assume that is all the members is having same cross section, means the area is same. Let me represent this all area by A, and we take this column as a reference point, this point as a reference point. Hence we take x bar A equals to 4A. 4 is nothing but the distance and this is area. We know how we calculate the centroidal axis. X is a1 x1 plus a2 x2 plus dash 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 a1 an x1 upon all area, that is a1 a2 a3 a4 and dash 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 dash. Likewise we are calculating the centroidal axis. So here we take A as a reference point, hence x1 into a1, that is 4 into a, x2 into a2, that is 4 6 plus 4 means 10 into a, and divided by total area a means 3a. Here hence we directly get x bar equals to 4.667 meter from A. This is the location of centroidal axis from A. So this is centroidal axis, which is 4.667 meter from this column. Now moving towards our second step, that is axial force in the column. This is one of also main step. Here we use our second assumption. So this is the distances of these stresses. Here v1 v2 and v3 are the forces, axial forces in the column. So x1 x2 and x3 is nothing but the respective distances from the centroidal axis. So these are the values of x1 is nothing but 4.667. so x1 is the distance of this force v1 from the centroidal axis. x2 is nothing but the distance of v2 from the centroidal axis, and x3 is nothing but the distance of v3 from the centroidal axis. So what we get here. Now moving towards our assumptions, we made assumption that is direct stresses in the column, that is direct stresses in the column due to horizontal forces are directly proportional to their distances from the centroidal axis of the frame. So V is nothing but the axial force in the column and A is the area, hence V by A is nothing but the stress, and the stress is directly proportional to their distances from the centroidal axis. Here is the distance of this stress, hence V1 by A upon x1 equals to V2 by A upon x2 and V3 by A upon x3. So all this area is common, hence we cancel it out. Hence we get V1 by x1, V2 by x2 and V3 by x3. Just put all the value what we know. We know value of x1 x2 and x3. Just put it and convert this equation in terms of one unknowns, means to convert V2 in terms of V1 and V3 in terms of V1. So we get V2 equals to 0.143 V1 and V3 equals to 1.143 V1. Okay, Now moving towards this step, that is summation of movement at 0 equals to 0. Summation of movement at O equals to 0. So this is the O point, means take the summation of all the forces about this point. So v1 x1 plus v2 x2, that is v1 into x1 plus v2 into x2, v3 into x3. X3 is the total distance, and this is 30 into this distance, that is h by 2. That is h by 2 means 1.5. So just put all the values. You know x1, we know v2 in terms of x1, so just put all the values. Here we have found out that is there is only one unknown, that is v1. So it is very easy for us to calculate the value of v1. So we get v1 equals to 4.144 kilonewton. Once we get the value of v1, we are able to calculate the value of v2 and v3 just by putting the value of v1 here. So we get v2 equals to 0.593 kilonewton and v3 equals to 4.737 kilonewton. So here we just calculate the axial forces in the column for the top story. Now next we calculate the axial forces in the column of bottom story. Same procedure what we did, same procedure we have to apply here. That is, this is the nothing but the distances of these forces from the centroidal axis. Here our assumption, that is we get v1 by x1 equals to v2 by x2 equals to v3 by x3. Just put all the values x1, x2 and x3. Convert this in terms of one unknown, that is v2 in terms of v1 and v3 in terms of v1. What we represent here, that is v2 is 0.143 v1 and v3 is 1.143 v1. Same procedure what we did in for the top story calculation. Okay, so just take the movement at this point, movement at O equals to 0, that is this is v1 x1 plus v2 x2 plus v3 x3 equals to p into h plus q into r, means two forces. So just put all the values. We know here only we have one unknown, it is v1, so it is very easy for us to calculate the value of v1, which we get 31.313 kilonewton. Likewise, once we calculate the value of v1, we are able to calculate the v2 and v3. So what I represent here, that is v2 is nothing but the 4.478 kilonewton and v3 is 35.791 kilonewton. Okay, now moving towards our main step. Here the calculation of shear force and axial force in the column and beam. Shear force and axial force in the column and beam. So make sure here we have to apply only three operations, that is summation of Fy equals to 0, summation of movement equals to 0 and summation of Fx equals to 0. That is summation of vertical forces equals to 0 in sequence wise manner. Go in this sequence, first, second and third. That is summation of vertical forces equals to 0, summation of movement equals to 0 and summation of horizontal forces equals to 0. So let's see how we apply these three operations here. And this is the joint method. I solved this example by using joint method, and I see this is one of the easiest method for solving the cantilever type of question. This is one of the easiest method. Okay, there are having some methods other, but I found this is one of the easiest way. So firstly take joint C. Our first assumption, point of contraflexures lies at the mid of the span. So this is once section is passes, so this is shear taken by the column and this is shear taken by the beam, and this is the axial force in the beam and this is axial force in the column, but we calculate the axial force in the column, that is v1 from our for the top story, that is v1 equals to 4.144 kilonewton. Just apply here summation of Fy equals to 0, taking all upward forces as positive. Sign convention is this, that is only one upward force, that is v1 is downward, hence minus v1 plus v equals to 0. there is no any vertical forces, hence we directly get the value of V, which is equals to 4.144 kilonewton. Sorry. Now second, apply summation of movement equals to 0 at this point. Summation of movement equals to 0 at this point, because by doing this calculation we get the value of h1. Hence 30 sign convention, all the clockwise movement as positive sign convention, hence 30 into 1.5 into minus V, what we calculated here, 4.144 into 2, this is 2, and minus h1 into 1.5 equals to 0. So we get h1 equals to 24.475 kilonewton. Now third operation, that is summation of all horizontal forces equals to 0. So 30, all this direction forces as positive taking, hence 30 minus 24.475 is h1 what we calculated here, and minus h equals to 0. So we directly get the value of h equals to 5.525 kilonewton. Just remember, this is one of the simple method, and for solving each joint you have to apply only 3 operations. Remember this in sequence wise manner, that is summation of fy equals to 0, secondly summation of movement equals to 0, and thirdly summation of fx equals to 0. By just applying these 3 operations you are able to find out the shear forces in column and beam and axial forces. Okay, let's see same operation for joint F. Next joint, we know the frame is in equilibrium condition, hence here what value get we here, it is exactly equal and opposite value we just represent here, that is h1 and v1. So here we get h1 in this direction, hence for the next one h1 in this direction, that is equal and opposite, because our frame is in equilibrium condition. Hence this is a joint F, the solving for joint F. Now h1 we calculated the value of h1 from our last calculation. V1 we know, V2 that is we calculated the axial forces in the column. Here we have to calculate the V, axial forces in the beam, shear in the beam, axial force in the beam, and the shear in the column. So we know first we have to make only 3 operations. First operation is that summation of fy equals to 0. So let's take all the upward forces as positive, hence here minus 0.593, downward edge, that's why negative, minus 4.144 plus V equals to 0. So we get V equals to 4.737 kilonewton. Second, summation of movement equals to 0. We're taking movement here because we have to calculate h1, hence this 24.475 into 1.5 minus 4.177, that is this one, 4.177 into 2 minus 4.737 into 3, that is V3, this V, and minus h1 into 1.5. So we get h1 equals to 9.476 kilonewton. So it is just a calculation part here. Just for the remaining portion we have to remember only 3 operations per joint, that is summation of fy, summation of movement, and summation of fx. So here by doing summation of fx we get the value of h, that is 24.475 minus h1 and minus h equals to 0. We get the value of h, which is 14.999 kilonewton. Okay, now moving toward our third joint, that is joint I. So here we found whether we done our last calculation right or wrong. here we find by using this summation. If this summation of fx equals to 0, we not get 0, means we done something wrong in the previous calculations. Okay, if we get here 0, that is summation of fx, we know that this frame is under equilibrium, hence we get summation of fi equals to 0. So here we get summation of fi equals to 0, means we done exactly accurately. Okay, we done accurately what we calculation do, are all calculations are accurate one. Hence we calculated here summation of fx, that is h1 is nothing but 9.476 kilonewton. Okay, now same calculation is we have to make for the bottom story. So let's take joint B here. These forces are equal and opposite because our frame is under equilibrium condition, hence we have to apply three operations: summation of fi equals to 0, summation of moment equals to 0, and summation of fx equals to 0. So just by doing these all operations, we get the value of, this is V, the value of 27.169 kilonewton. Here we get h1. So here I firstly take this as a direction of h1, so I got the value in negative sense, hence no, that is the direction of this h1 is in this direction. Okay, so h1 is 12.895 kilonewton, and third operation is summation of fx equals to 0. So check out, h equals to 18.420 kilonewton. Going toward our third joint, that is joint number E. Summation of fx, same. By doing summation of fx, we calculate, summation of fy. By doing this calculation, we calculate the value of v, which is we get 31.054 kilonewton. Summation of moment, by doing this we get the value of h1, which we get minus 43.235, because I take the direction of h1 in this direction, so I got minus value, means the value direction of this force is this one. I got the value, I just represent here the direction of h1 in this direction. Okay, and summation of fx, by doing this we get the value of h. So h is nothing but the 45.339 kilonewton. Next joint h, same procedure, summation of fx, summation of fy. So this is last joint, as we get the okay answer here. Once if you found summation of fy is 0, means what the calculation we did is accurate. Okay, once we get here 0, means our whole calculation is okay, and then as summation of fx we get the value of h, which is equal to 33.759. Once we calculated the all shear forces in the beam and column, our last step is calculation of movement. Once we calculate all the shear force in the beam and column, just do this diagram, just draw this diagram, because once you draw this diagram, it is very easy for doing the calculation of moment. As we know, that is height of this is 3 meter, this is 5 meter, and this is 4 meter, and this is 6 meter. Okay, so let's see how it is, how easy it is. So now we have to calculate the movement, our last step. It is movement from E to B equals to movement from B to A. Movement from A to B is nothing but the movement from B to A, which is 18. Shear force 18.42 into h by 2. So this shear force create the movement here in this direction, that is in this direction, hence 18.42 into h by 2, that is h by 2. H by 2 is nothing here, h is 5, h by 2 is 2.5, hence we get 18.42 into 2.5, which we get 46.050 kilonewton, which is nothing but the movement value of MAB and MBA. Same wise, once we calculated all the shear forces in the beam and column, it is very easy for us to calculate all the movements. Same calculation, that is MBC equals to MCB, hence equals to here shear force into H by 2, shear force into H by 2. This is nothing but H, so shear force 5.525 into H by 2, so we get 8.288 kilonewton. The same operation we have to apply for the remaining one, so we get all these values here, so this is the nothing but the complete procedure for solving the frame by using cantilever method. Just you have to remember one thing, take a joint, and for the each joint you have to solve for only three operations, that is summation of Fy equals to 0 in the sequence, summation of moment equals to 0, and third summation of Fx equals to 0. By just applying this operation we get the value of shear force, axial shear force and axial forces. Once we get this value of shear force and axial forces, draw diagram like this for the shear forces, and once we draw this diagram, it is very easy by using this diagram to calculate all the movements. So thank you.